So in this video, I'll teach you how to write Lewis structures. So before that, define muna natin kung ano ang Lewis structure. So Lewis structures give information about the following. Number one, atoms involved in the molecule and how they are bonded. So usually, ligands lang naman siya tsaka central atom. So hindi tayo magkakaroon ng very complicated Lewis structures sa chemistry. Next, meron tayong molecular geometry. So, naka-indicate na doon yung kung ano yung shape ng ating molecule. Although, naka-project lang siya in 2 dimensions kasi isusulat lang natin siya sa isang 2-dimensional paper. Okay? So, nakalagay na rin doon yung electron pairs. Naka-indicate kung alin doon yung bond at kung alin doon yung lone pair. And also, nakalagay na rin yung all possible resonance forms and yung charge ng ating molecule. So, yung resonance forms, I'll discuss this sa mga susunod na page. Okay? So we have an example here. Write the Lewis structure of H2O. So ang unang-una yung gagawin, count the number of valence electrons because this is due to the valence bond theory. Valence electrons lang yung kailangan natin. So sa oxygen, we have helium 2s2 2p4. So meron siyang 6 valence electrons, yung 2s2 and 2p4. So sa hydrogen, dalawa siya. Okay? Dalawa yung ating hydrogen atoms. So 1s1 per hydrogen. So ibig sabihin, 1 valence electron times 2, meron tayong 2 valence electrons. So i-add natin yung valence electrons nila. So ibig sabihin, 8 valence electrons dapat yung nag-i-exist doon sa ating Lewis structure. Okay? So next, i-connect na natin yung mga atoms. Of course, yung oxygen, yung magre-receive ng dalawang hydrogen. Kasi yung hydrogens, isa lang ang pwedeng atom na mag-bond dun sa hydrogen kasi isa lang ang kanyang electron. Okay, so isang electron available for a single bond with another atom. So yung oxygen, according to the Lewis electron dot structure, dalawa yung available niyang electron for covalent bonding. So isusulat na natin yung Lewis structure niya like this muna. Okay, so yung oxygen nakakabit siya dun sa dalawang hydrogen. So we have this. Tapos, the other 4 electrons will be located at the oxygen atom. Kasi again, yung hydrogen nyo, hindi siya pwedeng mag-accommodate ng more than 1 or more than 2 electrons kasi 1s lang ang kanyang orbital. So, ibig sabihin, hanggang 2 electrons lang yon. Yung oxygen, pwede siyang mag-accommodate ng up to 8 electrons around its atom. So, ayan, meron na tayong lone pairs dito sa oxygen. So, overall, merong 2 lone pairs and 2 bonding pairs ng ating oxygen. So, meron siyang 8 electrons, which is equal to the total number of valence electrons of water. Okay? So next, i-check natin yung formal charge. So to be able to calculate for the formal charge, bilangin muna natin yung valence electrons, minus ilan yung bonds na na-form, minus ilan yung non-bonded electrons. Okay? So for oxygen, 6 yung kanyang valence electrons, minus 2 bonds, minus 4 electrons kasi dalawa yung lone pair, equals 0. Sabihin, walang charge yung ating oxygen. 0 ang formal charge. Sa hydrogen naman, isa lang ang kanyang valence electrons and isa lang ang kanyang bond. So, total of 0. Ganun din dun sa isang hydrogen. So, the formal charge of the whole molecule is 0, meaning ang ating molecule ay neutral. 0 ang charge. Okay? So, finally, adjust natin yung geometry. Since ang ating water ay may dalawang lone pair and dalawang bonding pair, that's AX2E2. So, the molecular geometry is bent. So, this is the final Lewis structure of your water molecule. Okay? So, makikita natin dito na since bent siya and meron siya mga polar bonds, yung mga OH bonds, water is also polar. Okay? So, next example, write the Lewis structure of PCl3. Okay? So, ang una natin gagawin, again, is to count the valence electrons. Yung ating phosphorus ay neon 3s2 3p3. So, ibig sabihin, meron siyang 5 valence electrons. Yung ating chlorine ay 3s2 3p5. Okay? Neon 3s2 3p5. So, ibig sabihin, meron siyang valence electrons na 7. So, tatlo yung ating chlorine. Therefore, 7 times 3, it's 21 valence electrons plus 5 valence electrons. Total of 26 valence electrons. Okay? So, i-connect na natin agad yung tatlong chlorine dun sa phosphorus kasi obviously yung ating phosphorus dyan, yung ating central atom. Okay? Bukod dun sa obvious reason, phosphorus is less electronegative than the 3 chlorines. Okay? So, yung phosphorus, siya yung mas nakakapag-donate ng electrons kaysa sa chlorine. At also, dun sa Lewis electron dot structure natin, phosphorus can share at most 3 electrons sa 3 different atoms. Yung chlorine natin, sa isang atom lang siya makakapag-share ng isa niyang unpaired electron. So, this is the preliminary structure. So, the total valence electrons there is 6 kasi meron tayong tatlong bonds. So, 2 electrons per bond. Meron tayong total of 6 electrons na dun sa structure. Ngayon, i-distribute muna natin yung mga electrons sa ligands. So, dapat kapag nag-distribute kayo ng electrons, each ligand should have a total of 8 electrons around it. So for example, this one, meron siyang 6 na electrons na non-bonding electrons. Tapos meron siyang bonding electrons na dalawa. So 6 plus 2, 8 electrons yan. Ganun din dito at dito. Okay? So each chlorine has 6 non-bonding electrons and 2 bonding electrons. So 3 lone pairs and 1 bond. So meron siyang total of 8 electrons per chlorine. So after nyan, okay na. Pero meron pa rin tayong 24 electrons na nadidistribute in total. Okay? So yung last 2 electrons, since 26 yung kailangan natin i-distribute, ilalagay natin sa phosphorus. Okay? So ang gagawin nyo muna kapag isusulat nyo yung Lewis structure, i-distribute nyo muna lahat ng electrons sa ligands. So dapat tig 8 electrons per ligand muna, tapos kung may sobrang electrons, ilalagay nyo siya sa central atom. So meron na tayong lone pair dito sa ating phosphorus. So ibig sabihin, nakompleto na natin yung total valence electrons na 26. Okay? So ngayon, i-check na natin yung formal charge ng bawat atom. So for phosphorus, 5 valence electrons minus 3 bonds. Okay? 1, 2, 3. Tapos meron siyang 2 non-bonded electrons. So 0 ang kanyang formal charge. For chlorine, since pare-pareho lang naman siyang chlorine, isang calculation na lang ang gagawin natin. 7 valence electrons minus 1 bond per chlorine minus 6 non-bonded electrons. So 0 din yung total or formal charge ng ating chlorine. So the total formal charge for the whole molecule is still 0. So yung ating PCl3 ay neutral molecule. Okay? So finally, we need to adjust for the geometry. So PCl3 molecule type is AX3E kasi meron siyang isang lone pair, tapos meron siyang 3 bonding pairs. So ang itsura niya dapat ay trigonal pyramidal. That's PCl3's molecular geometry. So i-adjust natin siya like this. Okay? That's PCl3. So that's the final Lewis structure. So for the polarity, tingnan natin yung mga moments or dipole moments. Okay? So chlorine is more electronegative than phosphorus, so therefore we have such vectors. So since hindi nagka-cancel yung mga vectors, the net dipole moment is this one. Okay? So therefore, polar si PCl3. Although PCl3 is not very polar kasi magkalapit lang ang phosphorus at chlorine sa periodic table. So hindi masyadong magkalayo yung kanilang effective nuclear charge. Okay? So another example, write the Lewis structure of the perchlorate anion Cl4-. Okay? So again, yung unang step ay count all the valence electrons. So for chlorine, we have 7 valence electrons. Okay? That's 3s2 3p5. Yung ating oxygen ay 2s2 2p4. So that's 6 valence electrons per oxygen. So that's times 4, 24 valence electrons for the 4 oxygen atoms. So meron pa siyang extra charge because of the negative charge there. So we have another electron. So 7 plus 24 plus 1, we have 32 valence electrons. Okay? So next, i-connect natin yung mga atoms and mag-assign tayo ng mga electrons sa mga atoms. Okay? So chlorine is the central atom because the electronegativity of chlorine is less than that of oxygen. Electrons are assigned to the ligands first. Okay? So yung mga oxygens muna bago yung chlorine. So 8 electrons per oxygen were assigned. So meron tayong a total of 32 electrons assigned dun sa structure. So since 32 yung total na electrons natin, okay na siya. So this is our preliminary Lewis structure. So next, check natin yung formal charge. So the formal charge for chlorine is 7 valence electrons minus 4 bonds, 1, 2, 3, 4. Okay? Minus the number of non-bonded electrons. So wala tayong lone pairs sa chlorine. So that's 0. So yung chlorine ay mayroong formal charge na positive 3. So for oxygens, 6 minus 1 minus 6. So yung 6 natin ay valence electrons, 1 bond per oxygen, tapos 6 non-bonding electrons. So meron tayong 3 lone pairs dyan. So meron tayong negative 1. So times 4, that's negative 4. So plus 3 minus negative 4, ang total niya ay negative 1. So yung ating perchlorate, ClO4, ay may negative 1 na formal charge. So this is correct, yung ating formal charge. Pero positively charged yung ating central atom, tas negatively charged lahat ng ligands. So para ma-minimize natin yung charge separation na to, kasi this is unstable. Okay? Perchlorate is a covalent compound, pero marami siyang charge separation. So, pwede natin ma-adjust yung structure such that ma-minimize natin yung formal charges between the chlorines and the chlorine and the oxygens. Okay? So, adjust natin. So, pwede nating i-donate yung isang lone pair ng oxygen or 1 lone pair per oxygen para gawin nating bond. So, yung lone pair ng oxygen 1, 2, and 3 naging ano na siya, bond. Okay? So, nabawasan ng lone pair yung oxygens 1, 2, and 3, tapos ginawa natin siyang bond. Okay? Kasi, corresponding to the plus 3 formal charge of chlorine. So, kung plus 3 yung formal charge, pwede tayo mag-donate ng 3 electrons dun sa chlorine para ma-neutralize natin yon. As long as negative 1 yung formal charge naman ng ligand. Kasi kapag dinonate mo yung isang electron at negative 1 yung formal charge mo, magiging 0. So, tingnan natin kung ano nangyari nung ginawa natin to. Okay? So, for the chlorine, so 7 ang kanyang valence electrons, minus 7 bonds, 2, 4, 6, 7. So, 0 na yung kanyang formal charge. Okay? For oxygens 1, 2, and 3, since pare-pareho sila ng bonding state, so 6 valence electrons, minus 2 bonds, kasi double bond sila. Okay? Minus 4 non-bonding electrons, that's a total of 0. Okay? So, for the oxygen 4, 6 valence electrons minus 6 non-bonding electrons minus 1 bond is negative 1. So, total niya ay negative 1. So, finally, we adjust the geometry. So, ClO4 minus molecule type is AX4 kasi wala tayong lone pair around the chlorine, which is the central atom. So, tetrahedral ang kanyang geometry. So, this is the final Lewis structure for your perchlorate. So, kapag ka may charge, i-enclose nyo siya ng bracket, tapos ilalagay nyo yung charge sa upper right corner. So, kapag ka, negative 1 yung charge niya, you just put negative 1 doon sa upper right ng ating Lewis structure. So, nasa labas siya ng bracket. Okay? So now let's proceed to resonance structures. So resonance structures are a consequence of orbitals being adjacent to each other, tapos halos pareho rin sila ng energy. So kung may electron yung isang orbital, pwede siya mag-jump dun sa susunod na orbital kasi pareho lang naman din ang kanilang energy at yung orientation ng orbitals na yun. So nagkakaroon ka ng in-phase na orbitals due to constructive interference kapag ka medyo nag-overlap or pagkalapit yung mga orbitals na yun. Okay? So, resonance structures are different representations of the same compound. Kasi same energy lang din yun. Okay? Nagkakaroon lang siya ng iba't ibang representations due to the transferring of electrons from one orbital to another. So, more resonance structures, more stable. Kasi mas nakapag-travel yung electron mo throughout the molecule. So, ibig sabihin, mas nasa-stabilize yung ating electron. Okay? So, as an example, write the resonance structures of the perchlorate anion. So makikita nyo dito na since pare-pareho lang naman silang chlorine-oxygen bonds, yung mga single bonds na may formal charge na negative 1, pwedeng mag-donate ng electron dun sa chlorine para magkaroon siya ng 0 na formal charge. Pero kapag gagawin niya yon, dapat yung isa doon sa mga double bonds na oxygen or mga double bonded na oxygen sa chlorine, kukunin nila yung kanilang electron. Okay? So makikita nyo dito na nag-donate ng electron pair yung iyong oxygen dun sa oxygen-chlorine bond para magkaroon ka ng double bond. Pero kinuha din ng isa yung kanyang double bond o ginawa niyang lone pair yung kanyang double bond with the chlorine. So binawi niya yung electron na yun. Okay? So magkakaroon ka ngayon ng ganitong result. So magiging double bond na yung oxygen na to. Okay? Tapos yung oxygen na nasa itaas ay naging single bond na lang na naging negative 1 yung kanyang formal charge. So makikita nyo na pwede rin natin gawin yon sa ibang oxygen. So ito, nag-donate siya ng lone pair niya, ginawa niyang bond. Okay? Tapos kinuha naman ng isa yung kanyang double bond, ginawa niyang lone pair. So nangyayari yung ganitong resonance para ma-conserve natin yung formal charges ng ating chlorines tsaka ng oxygens. Tsaka para ma-conserve din natin yung total formal charge ng ating molecule. Okay? So pwede nyo gawin to sa mga ibang molecule na may nag-exhibit ng double bonds. Okay? So as long as nakakapag-accept ng double bonds or nakapagbigay ng double bonds yung inyong mga ligands. So for example, kapag hydrogens do not exhibit double bonding. Okay? Usually. So hindi nyo po pwedeng donatan ng electron ang hydrogen, for example. So mga molecules lang like oxygen, okay, and other chalcogens yung pwedeng magkaroon ng double bond. So pwede rin yung mga nitrogens, yung nitrogen, for example. So kapag ka ganon, okay, i-mind nyo yung number of electrons around the ligand. Kasi hindi po pwedeng sumobra sa 8 yung electrons na nasa ligand. Okay? So, kapag ka alam na natin lahat ng resonance forms ng ating perchlorate anion, we can now write the complete Lewis structure of the perchlorate anion. So, the complete Lewis structure is such that nag-iiba-iba lang, okay, yung position ng ating oxygen na may formal charge na negative 1. Okay? So, here we have some notes on resonance forms. So, for number 1, charge separation is avoided as much as possible. So, for example, we have CO2. Okay? We have a resonance form or a structure here wherein yung oxygens at carbons nyo ay 0 yung formal charge. So, let's check. For oxygen, we have 6 valence electrons minus 2 bonds minus 4 non-bonding electrons, we have 0. So, sa carbon, 4 valence electrons yung ating carbon minus 4 bonds minus 0 non-bonding electrons around the carbon atom, so we have 0. Okay? So, 0 lahat ng formal charges. So, as much as possible, dapat most ng atoms natin ay may 0 na formal charge. Okay? So, mas stable yung ganong klase ng structure kaysa sa structures na may charge separation. So, sa example na to, hindi siya masyadong stable kasi -1 yung formal charge ng ating mga oxygen, tapos +2 yung formal charge ng ating carbon. So, pwede namang mag-donate ng electrons yung ating oxygens para mag-double bond na lang sila at mag-zero na lahat ng formal charges. So, kung meron tayong possibility ng mas stable na Lewis structure, yun yung ating isusulat. Okay? So, for the next one, the more electronegative atom often receives the electron pair. This is logical kasi kapag mas electronegative ka, mas mataas yung tendency mo na mag-hold ng electrons kaysa magbigay. Okay? So, nagbibigay ka lang ng electrons if necessary, pero most probably, lalo na kapag sa resonance forms, you often receive the negative charge. So, kapag ka ligands, for example, na mas electronegative, yung mga formal charges nila is either negative or zero. Hindi ka po pwedeng magkaroon ng ligand na nagpa-positive yung formal charge, lalo na kung siya yung mas electronegative. Okay? So, for example, we have HCN. So, sa HCN, we can construct another resonance form by donating this bond, gagawin nating lone pair ng nitrogen. So, this is the more stable form. Kasi yung nitrogen ay mas electronegative sa carbon, so therefore, yung nitrogen yung mag-hold ng negative charge. Pwede itong structure na to. However, dito sa isa, sa carbon na donate yung electron, so nagkaroon siya ng negative charge, tapos positive yung iyong nitrogen. So, this is less stable kasi carbon is less electronegative than nitrogen, so therefore, dapat yung carbon yung mas nagpa-positive, yung nitrogen yung mas nagne-negative. Okay? So, another note, yung ating first row, P block, okay, they are strict followers of the octet rule. Okay? So, kapag sa isang closed shell configuration, dapat 8 electrons lang. Hindi po pwedeng lumagpas ng 8. Pwede tayong magkulang ng 8 electrons. Okay? Pwede tayong magkaroon ng positive na formal charge. Pero hindi tayo po pwedeng sumobra sa 8. Okay? Pwede tayong magkaroon ng less than 8, so positive formal charge. But again, hindi po pwedeng sumobra sa 8. Hindi pwedeng maging 10 or 12. Okay? So, another note on the first block or first row P block elements. So, finally, for number 3, central atoms should not have negative formal charges. Okay? So, again, this is as much as possible. So, we have here the CO3 2-. Okay? This is the carbonate anion. So, ito yung final Lewis structure ng ating carbonate anion. So, try nyo siyang i-construct. So, dapat mag-arrive kayo sa ganyang klase ng Lewis structure. So, include nyo na rin yung resonance forms. Okay? So, pagka dinoy nyo yung resonance forms niya, makikita nyo dito na yung carbon, meron siyang 4 bonds. And the formal charge of this carbon is 0. Okay? However, dito sa isa nating resonance form, sa isa nating structure, -1 yung kanyang formal charge. This should be avoided. Again, because carbon is less electronegative than oxygen. It cannot hold more electrons than 8. Again, it is a strict follower of the octet rule. So, makikita nyo dito, 10 electrons na yung around the carbon atom. Okay? So, hindi to pwedeng resonance form. Okay? So, this is my discussion on drawing Lewis structures in resonance forms. Sa susunod kong lecture or sa susunod kong video, I'll discuss the molecular orbital theory. So, see you next video.